Hi again, this is Joseph, and today we'll be dealing with how to test a battery. And besides that, we're going to be talking about the side terminals, which is a problem, especially for GMs. The side terminals have corrosion on them, and these are the side terminals. This is a bad one, and you can see this is a good one. See the shininess? Now, customer complaint was when they start the car, they have difficulty starting the car, and when they put a booster, it doesn't boost. So right away they assume that possibly maybe it's the starter, because they tried the booster and it didn't start the car. So one advice was they told them to go, and when they went to another location, to go and change the battery. Obviously when I looked at it, I saw the first thing was that I know these have problems with the side terminals all the time. As I said, corrosion is a major problem. When you have corrosion on the leads or on these things, you have resistance. When you have resistance, you have a voltage drop. So it's like losing voltage in a series, and also the current gets reduced. So it's a big problem, and you're going to have starting problems. Now, there is a way to test these, or cables, or anything that you want. Usually people use a visual test. I don't use a visual test. I use the meter for everything. If you're going to go and use it, put on ohms, and I apologize for the photography until I get a real tripod, but if you do an ohms test, this should be like a short, because remember, this is 8 millimeter. This is connecting by terminals to the posts that are inside on the side. So assuming this is a conductor, right? And I apologize again for this. You put it on ohms, 200 ohms, and wherever I go, I should measure for very low. Here is rust, it's a problem. Here, I have to go back and forth until I find a place on it that is not rusted, is not corroded, to make good contact. So as you can see, it's a problem. So when you put the boosters over here, it's a problem. It's not really making contact. It's going to see how the numbers are fluctuating. You don't want that. Now, let's look at a good one. Okay, that's a bad one. See shiny? That's a brand new one, 8 millimeter. The booster is going to go on this side. This is where the probes go. Let's see the difference. Okay, this is one side. Okay, let's look at the other side. Look at that. Right to 0.4 ohms. Look at that. Wherever I go, I don't know if you can, hopefully you can see it. 0.3, 0.4. See? It goes right to it when you make contact. See? 0.3, 0.4 ohms. That's what a good terminal should be. No battery was needed. Had to be cleaned from corrosion. And when we clean, usually we use, well, in this case, on side posts, you can't really clean these, you just replace them. But on the top post, what you use is, usually use for battery, on the top post, you put this end in. The other one, you scrape the cables. And I'll show you when I have the top posts. So that's that. Now, that's how you know if you have a good connection on the cable terminals. Always do an ohms check. Always. That will take out any doubts in your mind. The meter speaks 100 words. So we know that's how you do it. Now, there's something over here, a battery tester, as you've all seen. You've all seen battery testers. Now, there are different types of battery testers. One battery tester is, the analog one, is where you put a carbon pile, a load, on the battery, and current flows through it. Now, that load gets hot, and it determines how much the voltage is. Remember, for a good battery, at about 70, 80 degrees, you need minimum of 9.6 volts. It should not drop beneath that. That's at 70, 80 degrees. Now, we use the unit cold cranking amps. That means it was tested at 0 degrees and it didn't fall below 7.2 volts. So the criteria changes as the temperature degrades, because obviously the chemical reaction of the battery degrades with the temperature, the environmental temperature. So therefore, we give it a little more room. So instead of 9.6 at normal, as you go down in temperature, 9.1, 9.1, 9.0, 8.6, it depends on the temperature. So the minimum goes as the temperature goes. Now today is about right now around 70-degree day. So the temperature, the battery likes 70 degrees, 80 degrees. The cold cranking amps over this, it's 875. So we're going to put in some meters, as you know. Actually, the cold cranking amps is 700 amps. So we're going to put in half of that. Some of these meters, you put the whole cold cranking amps, or you put half of it. So remember, at 32 degrees is cranking amps, 875. At cold cranking amps is the lesser current, is 700. So the cold cranking is always less. Now, when I turn on the alternator, obviously it turned on, so I know the battery is good. Or is it? Let's find out. Could have been a hard start to get it started. So there was a surface charge. Surface charge meaning there was 12.8. After the alternator, now I disconnected it. You let it drop. So I let it drop to around 12.47, around that. Okay? So now, hopefully you see it. So we said around 700 cold cranking amps. So we're going to go down. So what's half of 700? 350. Okay. So these work a different way. The other ones work by current flowing through from the battery to the load on the meter. The analog ones, the carbon piles. And you can tell they are very thick cables on those. These are very thin cables. Very thin, because no current goes through it. The way it works is each battery has a resistance, an internal resistance in milliohms. Now you've heard of kiloohms, you've heard of mega ohms. Milliohms is 1,000 of an ohm. The internal resistance of a battery at this temperature should be in the milliohms. That's what we want. If it as it discharges, when you use it, its resistance gets worse. That means the current gets worse. So therefore, this determines that by measuring the resistance and then figuring out how much current it can deliver. Almost like Ohm's law. I'm sorry. Almost like Ohm's law. Probably is Ohm's law. So we're going to do a simple test over here. We're going to do test, and it tells you so easily pass. Let's try it again. 1248 is the voltage. That's 625. That means it can crank 625 cold cranking amps. Now remember, we needed 700, so that's within the spec. Not bad. But this is at this temperature, 70, 80 degrees. What happens if you're on 20 degrees or 0 degrees? What happens if you go to Wisconsin, somewhere out there, right? Where it's much, much colder in the winter. So therefore, we have to take into consideration the temperature. This is why I made this video. This, as you can see over here, has a button over here. Cold test. Temperature compensation. Many of them do not have a temperature compensation. So it takes into account the temperature of the battery as you program it. So let's say it's around 70 degrees right now, which the battery likes, right? It's going to program it 70 degrees, which it is, and it's going to tell you at that temperature, is it good? So hopefully you can see it. Right. 200. Okay, it gives you a pass. That means at that temperature it passed, and it tells you how much the current is. No, I haven't seen too many of these type of testers. That's why I did this video, that could compensate for the temperature. And that's this whole point of this video. You have to understand, at that temperature, 70-80 degrees, it's good. What happens in the winter when you tell the customer, oh, you know, this battery is good, but maybe it's not good? So with the other one, the carbon power, the analog ones, if you see it, and I'll show you later on the video, if you see it on a certain region, on the green region, and it goes below, even though it passes, I would disregard that battery, because in cold weather you're going to have problems, even though it's in a passable region. This tells me right away if it does a temperature test. It tells me right away if it's good. This is why I like this type of meter. This is from years ago, cost over $200. I don't know, probably less today. But anyway, the theory is the same. You want to test it, put a load on it. Right? That's what the other one does. This measures the resistance of it. Internal resistance degrades as the battery degrades. It's like an internal resistor in series with it. And what do you have when you have a resistor in series? You lose voltage over it. The more voltage internally, the less voltage it gives out to the load or whatever you have it supplied to. So remember, don't rely on just measuring the voltage of 12.33, that's 0.44. That's not enough. You have to do a load test, or you have to see how much the resistance of it is and how much current this can deliver. And remember, corrosion, you can measure corrosion like I just showed you. Very many times there is a problem on the battery, not the actual battery, but the actual terminals and these type of screws that I showed you right here, that are corroded and rusted, and it's hard to find a point that actually made a contact. That's why the best thing is just change them on the side ones. These are very cheap. Okay, so anyway, thanks for subscribing. See my channel, Joe Electronic Schematics from Auto. And there's another test that can be done, and hopefully you can do it. Okay, first take away this, and what I like about this, when you don't have a good connection on either one of them, on the lead, it'll tell you the lead, like black lead or red lead is not connected. So you know which one is not connected properly. That's what I like about it. Let's go to the other one, the regular one. Again, apologize for the photography. Hopefully when I get a tripod, things will be looking a little better. Okay. Now, simple. I'm putting this on millivolts. Now, we're gonna go over here. Now, there's such a thing as leakage. Doing a leakage test. When you have a crack or leakage current, you have voltage drops. Therefore, when you go to the case of the battery, you should not have a significant amount of voltage drops. That means there's a problem. Like whenever you have corrosion or something like that, especially the white corrosion that you have to clean on the top post, you should look for or make sure that the case itself does not have a significant amount of voltage drops. That means you have leakage at the battery. That's the first thing that I do. As you see over here, wherever I go, it's very low because this is in the millivolts. I'm on the millivolts scale. This is the millivolts. I didn't put it on 2 because you won't see it. So whatever I measure is 0.4 millivolts, 0.2 millivolts, and that's what we want. The other thing that I always recommend to the customers, always increase the cold cranking amp. It doesn't matter the company, Duralast, Interstate, it doesn't matter the battery. In cold temperatures, the battery strength goes down about 60%. And you can crank about twice the current. So therefore, increase this cold cranking amp. If it's 700, increase it to 800 to 900 to 1,000. In the winter, just start it right up. All the customers, they have the batteries for 4 or 5 years, never had any problems. That is not the company, it's the cold cranking amps that you should increase. Remember, you get more current you have to draw at cold temperatures. The fuel injectors are longer, the pulse width, the alternator is at a higher voltage, and everything is colder, so you're pulling more current just to crank. So if you want to see the terminals, hopefully I get a real tripod. Hopefully, I hope you can see the terminals. I don't know if you can. These are the terminals. See how clean they are? Big difference. A big difference from the rusted ones. Also, the ground ones also become rusted. You have to clean them off, otherwise you're not making a good contact with your probe, and you'll think it's a ground problem, which it is, but you have to take off the rust. So therefore, even though this is a Duralast, as you see over here, see the ratings? Increase the ratings. It would help you, especially in cold weather. I hope this was helpful. I'll make another video about the other carbon pile test, which uses the analog one. The other one does not have temperature compensation. That's why I like this one. As I showed you, it does have temperature compensation. So anyway, please help me with the views, the minutes. There was someone who asked me, 8 years ago I started the channel, I did 2 videos that flopped, they bombed. I never did any videos until 2 years ago, almost 2 years ago, when I started doing this channel again. This channel is not, I have not done this channel for 8 years. Like I said, I started 2 years ago, almost 2 years ago in November, doing this and making all these videos and really putting a lot of effort into it, as you can see. So 2013, it says that date, and I did it, and I did something related to electronic. It totally bombed, and I gave up on it. But I decided a couple of years ago to instruct and teach people. So please help me with that, achieve my goal. Anyway, I hope this was very informative, very helpful. And remember, when you do these side ones, I hope you can see this. I hope you can. Leave these on. See these protective ones? Leave these on. They are for protection for rust and corrosion. So leave these on. Do not remove them, and leave the actual wire over there. They are for protection. Okay? Thanks for watching. See you in the next video for the other carbon pile tester.